Hello and welcome to the 6.3 notes. And this is a section about testing whether or not we have a parallelogram. And so what I want to do is, we kind of want to use the idea of what we've already learned about in 6.2 about parallelograms to help us determine whether or not we have a parallelogram. So I'm just going to kind of jump right in here and talk about number one, and we want to determine whether each quadrilateral is a parallelogram, and we want to justify our answer. And so what we can say here about number one is that we can actually say that this is a quadrilateral, so we could say yes. And the reason is because one pair of opposite sides rather, is parallel and congruent, okay? So we can go ahead and say that. If we've got one pair that's parallel and congruent, you can assume that it's a parallelogram, okay? Let's take a look at number two. Number two, I notice that I've got opposite angles are congruent. All right, and that is one of the definitions we have, or one of the properties we have of a parallelogram, so we would say yes. Okay, we would say that opposite angles are congruent, okay, which gives us a parallelogram, which gives us a parallelogram. Okay, the other thing we can say in number three, we only have one pair of sides that's congruent, okay? And that's not enough to tell me whether or not this is a parallelogram. So I would say no, because we have only one pair of congruent sides. Okay? We would need two pairs. Okay, so let's take a look at number four. Number four, this is a parallelogram. We would say yes, okay, because opposite sides are congruent. Okay, and that's all we need to say about that, all right? So let's go ahead and take a look at numbers 5, 6, and 7. And I want to go ahead and take a look at number 5, and it says that graph each quadrilateral with the given vertices, determine whether the figure is a parallelogram, justify your answer with the method indicated. So what we want to show here in number 5 is we want to use the slope formula to determine whether or not we have a parallelogram. So I'm going to come in here and I'm going to plot these points on this graph. So I'm going to plot the point 0, 0. Okay, I'm going to plot the point 3, 4. So 1, 2, 3, 2, 3, 4. Plot a point there. Okay, I'm going to plot the point 7, 4. 7, 4. Okay, and then 4, 0. 1, 2, 3, 4. Okay, so I'm going to call this point P, call this point Q, call this point S, and call this point T. All right, I'm going to zoom in, and I'm going to connect these with lines. So I'm just going to draw a line going across. It's not going to be perfect, but we'll get the idea. Okay, and then got that, and I've got that. Okay, so what I want to do is I want to use the slope formula to determine whether or not this is a parallelogram. So I'm going to find the slope of PQ, and I'm going to see if that's the same slope as TS, okay? And I'm going to use the slope of QS and the slope of PT. Now, here's what I know. I know that the slope of QS, I'm going to write that, the slope of QS, M is equal to 0, okay? Slope of 0, it's a horizontal line, okay? And the slope of PT, and the slope of PT, okay, M is equal to 0. Okay, so I know this. I can then conclude that segment QS is parallel to segment PT, okay? They have the same slope. Okay, so I'm going to come in here and say those are the same, so those are parallel. Okay, so that's one pair of opposite sides are parallel. Now let's go ahead and take a look at QP. Let's find the slope of QP. So slope of QP, okay, and that's equal to, and I'm going to do this. I'm going to draw a triangle that shows my rise over my run, okay? And notice that I go up 4 and then over 3. And because we're going in this direction, I know it's positive. So the slope of QP is 4/3, okay? And then I'm going to do the same thing with ST. I'm going to do the slope of ST, okay? And actually, I'm going to do this. I'm going to kind of erase this. I'm going to put the slope M is equal to 4/3. Okay, slope of ST, okay, M, what is that? Okay, and so I'm going to do the same thing. I'm going to draw another triangle, another right triangle. Okay, I know that this is 3 and this is 4, so my rise is 4, and I run 3, and since I'm going in this direction here, I know it's positive, so I have a slope of 4/3. Okay, and you guys could use the actual slope formula, with the, using the points and all that. That works too. Provided you have a graph, you can do whatever you want. I just want you to make sure that you get the correct slope. So, but here's the conclusion that we can draw. We have the same slope here. Okay, so because that's the same slope, then I know that QP, okay, segment QP is parallel to segment ST. All right? So because I have both of those statements, then I know I can then draw a conclusion about this, okay? And I can say that quadrilateral PQST, okay, hold on, is it PQST? All right, so my conclusion that I draw, and this is the symbol for conclusion, okay, those 3 dots. And the way that I kind of know that it's conclusion, it's by the number of syllables, conclusion, okay? And I'm going to say that quadrilateral PQST is a parallelogram, because the opposite sides are parallel. Okay, and that's it. That's all I need to say here. Okay, so that's number 5. Okay, so we'll need to use the slope formula, sometimes the distance formula, and all that. So let's go ahead and take a look at number 6. Let's do that one. And I want to go ahead and plot these points. So I've got the point -2, 1, and that's point S. Okay. I've got the point 1, 3, that's R. Got the point 2, 0, and I've got the point -1, -2. Okay, so I'm going to call this S, R, T, and Z. Okay, I'm going to zoom in and connect these points. So I've got this, and this, and this, and this, okay? And so, it doesn't matter which one of these I want to choose, but it wants me to use the distance formula and the slope formula, okay, to figure out whether it's a parallelogram. So what I'm going to do is I'm just going to choose SR and ZT, okay? So I'm first going to find the slope of SR, okay? And then I'm going to find the slope of ZT, okay? And that's my slope is equal to something. Okay, so what I want to do is I'm going to go ahead and just draw in those triangles here. I'm going to draw my right triangle in, going up 2, and then over 3. So up 2, over 3. And the same thing over here for zt, okay? So I rise up 2, go over 3, okay? Now they're both going in this direction here, so I can go ahead and automatically conclude that they're both positive, okay? We rise up 2, go over 3 for SR. We rise down 2 and to the left 3 for ZT. So let's go ahead. For SR, I have a slope of 2/3, okay? And then for ZT, I've also got a slope of 2/3, okay? So because these numbers are the same, okay, then I know that SR is parallel to ZT, okay? They have the same slope, so they're parallel. All right, now I want to find the distance, okay? And so if I wanted to find the distance of SR, okay, then I know that I can use the Pythagorean theorem, and I'm just going to go ahead and do this. I'm going to write the square root of 2 squared plus 3 squared, all right? And that's going to give me the square root of 4 plus 9, which gives me the square root of 13. Okay, so SR has that distance of the square root of 13, all right? And so then I'm going to do the same thing for ZT, okay? And so I want to calculate the distance of ZT, all right? And so I'm going to use my Pythagorean theorem or distance formula, and I get 2 squared plus 3 squared. Okay, I get the same thing that we had in the other one. All right, we have this right triangle, and I use those sides to set up the Pythagorean theorem or the distance formula. And we give the same thing here as we have here. So since we've already done this math here, since we've already found that SR is the square root of 13, we need to set this up, but we don't need to go through all that work again. We can automatically just conclude that ZT is equal to the square root of 13. Okay, and because these distances are the same, then we know that SR, okay, is congruent to ZT, okay? And all I need to show is that one pair of opposite sides are parallel and congruent, then I know we've got a parallelogram. So let's go ahead and draw that conclusion. So SRTZ, so I know this. My conclusion that I'm trying to draw is that quadrilateral SRTZ, is that right? Did I name that right? SRTZ. I got to go make sure I go around the figure like that. SRTZ is a parallelogram. Is a parallelogram because one pair of opposite sides are parallel and congruent, okay? And that's all I need to say about that, okay? So we have one more to do, number 7, and I want you to do this one on your own. Okay, I want you to do this on your own. Okay, and it wants us to use the midpoint formula. Now I'll give you this. Remember that in a parallelogram, the diagonals bisect each other. Okay? And that's what you need to do. Okay? You need to use the midpoint formulas on the diagonals. Okay? I'll let you guys do that on your own. Okay, number 8. Let's take a look at number 8. It says find x and y so that each quadrilateral is a parallelogram. So on number 8, I'll have you guys do this one on your own as well. On your own. Okay, I will do this. I will help you out here. I will show you that opposite sides have to be congruent. Okay, I'll let you set up equations and solve for that. Okay, but I will do number 9. Okay, number 9 I'll do with you. And it wants us to figure out what these values are. What I do know about parallelograms is that this segment is congruent to this segment, okay, and these two segments are congruent, okay? So I know that the diagonals bisect each other, all right? So I'm going to do this. I'm going to set up the equation 3x is equal to 4x minus 3, okay, and I'm going to set up the equation y plus 3 is equal to 2y minus 11, okay? So I can set those equal to each other because I know that they're bisected. And so if I solve for x, okay, and I'm just going to go ahead and subtract by 4x on this side and this side over here. That goes away. We're left with negative x is equal to negative 3. So then I divide by negative 1 and divide by negative 1. I find out that x is equal to 3. Okay? And I'm going to do something similar over here. I'm going to subtract by y on both sides. So I end up getting 3 is equal to y minus 11. I'm going to add 11 to both sides. And so then I get that y is equal to 14. Okay, and that's it. All right, so we're just setting up equations and solving just like we have been doing. So go ahead and do number 9 and number 8 on your own. Okay, and we'll check those in class. So I hope you enjoyed this video. I had a lot of fun making it. And we will see you soon.